In this video, I will teach you about definite integrals, which, among other things, gives you the area under the curve from A to B. If you appreciate the content, please give it a like. Up until this point, every integral you've seen has been an indefinite integral, and it looked like this. Definite integrals have numbers right here called the limits of integration. The indefinite integral just meant the function to the left in the chain of calculus. In other words, the indefinite integral of f of x would give you capital F of x, the function such that if you took the derivative, it would give you f of x back again. The definite integral of f of x from a to b means the area under the curve from a to b. For example, if this red curve is f of x, the integral of f of x from 4 to 12 means the area under the curve from 4 to 12, this yellow area. Since the indefinite integral means the function to the left on the chain of calculus, the answer to an indefinite integral was a function, like this for example. Since a definite integral means an area, the answer will be a number like 13.5 or 8 pi. This is the graph of f of x. It is composed of 4 line segments and a semicircle. Let's use this graph to calculate several definite integrals. The integral of f from 0 to 4 is the area under the curve from 0 to 4, the area of this triangle. We know the area of a triangle is 1/2 base times height, so that's 1/2 4 times 2. Of course, half of 4 is 2, and 2 times 2 is 4. You don't have to simplify these if you don't want to. The definite integral of f of x from 4 to 12 is the area under the curve from 4 to 12. The area of a full circle is pi r squared, where r is the radius, and this is a semicircle, so we'll be taking half of that. The radius is 4, so the area of the semicircle is 1/2 pi 4 squared. 4 squared is 16, and half of 16 is 8, so 8 pi. The integral of f of x from 12 to 20 is this area under the curve from 12 to 20. So how do we calculate this? Let's break the area up into rectangles and triangles for easy area calculation. This triangle is half of the square. The square has an area of 4, so this triangle has an area of 2. Base times height for this rectangle, or you can kind of count the squares, the area here is 8. This square obviously has an area of 4. We could do 1/2 base times height for this triangle, or we could see that the area of the rectangle is 8, and the triangle will be half of that, which will be 4. So we just need to add 2 plus 8 plus 4 plus 4 for the total area. That's 18. The integral of f of x from 0 to 20 is this area under the curve from 0 all the way to 20. So it'll be the sum of the 3 areas we just calculated. In other words, 4 plus 8 pi plus 18. You can either leave your answer like this, or you can write something like 8 pi plus 22. Let's talk about area above and below the curve. This is the graph of f, and it consists of 2 semicircles. And the semicircles have the same geometric area as this one. The radius is, again, 4. As before, each of these semicircles will have an area of 8 pi, because the area of a full circle is pi r squared, and this is going to be half of pi r squared. 1/2 pi 4 squared is 8 pi. The twist is, in calculus, areas have signs. When you integrate from left to right, like the integral from 0 to 8, areas above the x-axis are considered positive. So the integral of f of x from 0 to 8 is positive 8 pi. However, if you integrate from left to right, like the integral from 8 to 16, areas below the x-axis are considered negative. So the integral of f of x from 8 to 16 is equal to negative 8 pi. Whoops, I accidentally left off the dx on that one. Guess what the overall integral of f of x from 0 to 16 is going to be? Correct. We say the net signed area from 0 to 16 is 0 because 8 pi minus 8 pi is equal to 0. Pause the video and calculate these two integrals on your own. Are they the same? When you integrate from left to right, area above the x-axis is considered positive. For the area of this triangle, we do 1/2 base times height. The base of this triangle is 4, not 5. It goes from 1 to 5, which is a length of 4. So 1/2 4 times 2 is equal to positive 4. When you integrate from left to right, area below the x-axis is considered negative. So this integral is negative 4. When you calculate a definite integral, you're always going from the bottom number to the top number. So in this case, we are integrating from 5 to 1. Notice how that's backwards. We are now going from right to left instead of from left to right like we've been doing before now. When you integrate from right to left, everything is the opposite from what we've been doing. So an area above the x-axis like this, which normally would be positive, will now be negative. So this integral will be negative 4. An area like this one below the x-axis would be negative if we were integrating from left to right. But since we are integrating from right to left, it will actually be positive. Sometimes you have to perform some integral arithmetic. For the next few problems, we are given that the integral from 0 to 2 is equal to 5, and the integral from 0 to 6 is equal to 4. Using those two pieces of information, what is the integral of f from 6 to 0? If the integral from 0 to 6 is positive 4, then the integral from 6 to 0 must be negative 4. In other words, reversing the limits of integration changes the sign. The integral from 0 to 2 of 3 times f of x dx is very similar to this, but we have this extra constant of 3 in the front. It turns out that you can bring a constant outside of the integral without changing the value. So the original integral is equivalent to this one. But this part, the integral from 0 to 2 of f of x, is what we are given. The integral has a value of 5. So we can plug in 5 and we get 3 times 5, which is 15. I need you to really focus on this next one because it is the most missed problem on the test. The reason why is because multiplying inside of an integral and adding inside of an integral do not work the same way. We just saw that if you are taking the integral and you are multiplying by a constant, you can just bring that constant out unchanged. Students mistakenly think you can do the same thing with addition and just bring this 3 out like this, but this is incorrect. Instead, when you take the integral of a sum or a difference, you integrate term by term. So basically you split this integral into the sum of 2 smaller integrals. It's time for a very important side lesson. Let me quickly teach you how to take the definite integral of a constant. We just learned that the definite integral of f of x from 3 to 7 would be whatever this area is under the curve. But if f of x is a constant, like let's say f of x is equal to 5, then the graph is just a horizontal line, and the area under the curve from 3 to 7 is a rectangle. The area of a rectangle is base times height. The base of the rectangle will be, well, in this case it's 4, but keep in mind, looking at the limits of integration, it'll be the upper limit minus the lower limit. So yeah, the base is 4, but keep in mind that's 7 minus 3. The height of the rectangle is just the value of the function, in this case 5. So the integral of f of x from 3 to 7 is 4 times 5, which is 20. But remember, f of x is simply 5. So if we sort of plug that in right here, the integral of 5 from 3 to 7 is 20. Pause the video and see if you can tell me what the integral of 4 from 2 to 8 is. The integral is the area of this rectangle. The base of the rectangle is 6, 8 minus 2. The height of the rectangle is the value of the constant itself. So the integral of 4 from 2 to 8 is 6 times 4, which is 24. One more. What's the integral of 11 from 7 to 9? The integral of a constant is just going to be a rectangle. Base times height. The base is going to be 2 because 9 minus 7, and the height is 11. So the integral of 11 from 7 to 9 is 22. So let's write a formula for the integral of constant c from a to b. This will be the area of a rectangle, which will be base times height, where the base will be b minus a, and the height will be c. Getting back to the original problem, what is the integral of 3 from 0 to 2? Well, this is the area of a rectangle with a base of 2 and a height of 3. So the integral is 6. We were given this value. The integral of f from 0 to 2 is 5. So the value of this integral is 6 plus 5, which equals 11. Again, the super common mistake is kids think they can just bring out the 3 unchanged without actually taking the integral of it. So they put the wrong answer of 3 plus 5, and a lot of kids will put 8 on the test. But NERP, you have to take the integral of 3 from 0 to 2, which is 6. Now we need to calculate the integral of f of x from 2 to 6. I think a diagram will really help us on this one. Here is a generic sketch of f of x on the interval from 0 to 6. We were given these two pieces of information at the top. The integral of f of x from 0 to 2 is 5. Therefore, the area under the curve from 0 to 2, this area right here, is 5. We are also told that the integral from 0 to 6 is 4. That means the entire area is 4. So, the area from 2 to 6, and I'm suddenly seeing that this diagram doesn't really make sense with these numbers, but what does this missing area have to be if the net signed area is 4? Well, the missing area must be -1. So 5 and then plus -1 would give us a total of 4. Here's a better diagram of f of x now that I see how it kind of turned out. The integral from 0 to 2 is this area under the curve, which is 5. The total area has to be 4. The integral from 0 all the way to 6 is 4. That means this little area below the x-axis must be a -1. And that is what we were asked to find, the integral from 2 to 6. So that must be -1. Here's how it would look if you wanted to do it all algebraically instead of graphically. This is part plus part is equal to the whole. Let's fill in the facts we were given. The integral from 0 to 2 is 5. And we are looking for the integral from 2 to 6. So I'm just going to put like a question mark right here. And we are given the integral from 0 to 6, which is 4. So subtracting 5 from both sides, we get -1. You know the following is pretty important if they call it the first fundamental theorem of calculus. In this formula, I'm going to use capital F of x to represent the antiderivative of f of x, as is traditional. The first fundamental theorem of calculus tells us how we calculate a definite integral. We take the antiderivative of the function inside, I'm going to call that capital F of x, and we apply the limits of integration. We show it with a vertical line and then a to b, or whatever the numbers are. In turn, this notation means you take your antiderivative and you plug in the top minus plug in the bottom. Note that the first fundamental theorem of calculus only applies if f of x is continuous on the interval from a to b. This theorem works all up and down the chain of calculus. Remember, the antiderivative of f prime is f. The antiderivative of f double prime is f prime. So if I want to calculate the definite integral of g prime from a to b, first I take the antiderivative of g prime, which is g. And then I apply the limits of integration. And remember, this means take your antiderivative, which is g, and you plug in the top minus plug in the bottom. So that's g at b minus g at a. Vocabulary word. The function inside of an integral is called the integrand, and this is the graph of this integrand. We want to evaluate the definite integral of this function from -1 to 2. According to the first fundamental theorem of calculus, we first find the antiderivative. So using the power rule of integration, let's increase the exponent by 1, and then divide by the new exponent. 3 divided by 3 is 1, and we don't need to write that. Moving on to the next term. Increase the exponent by 1. Divide by the new exponent. -4 divided by 2 is -2. And the antiderivative of 2 is 2x. So plus 2x. This is the antiderivative, and it is time to apply the limits of integration. So you put a vertical line, and you write the limits of integration like this. Then the first fundamental theorem of calculus says you take your antiderivative and you plug in the top minus plug in the bottom. So here I've plugged in the top minus I've plugged in the bottom. If this was a test, you could actually leave your answer just like this. However, by points, half of the AP exam is multiple choice, so be able to simplify without a calculator like this. The answer would be 9. Remember, what we've just found is that this odd-shaped area under the curve from -1 to 2 is 9. Ooh, let's do a definite integral with trig. First, we need to find the antiderivative of secant squared. And we do that by asking ourselves the derivative of what is secant squared. We know that the derivative of tangent is secant squared, so tangent theta is the antiderivative. And then we apply the limits of integration by putting a vertical line, and we write the -pi/4 at the bottom and pi/3 at the top. The first fundamental theorem of calculus says we now plug in the top minus plug in the bottom. So here I've plugged in the top minus plugged in the bottom. Make sure you have memorized these 9 trig facts from AP Pre-Calculus, including the fact that the tangent of pi/3 is radical 3, and the tangent of pi/4 is 1. So here's the tangent of pi/3, which is radical 3. Like I said, the tangent of pi/4 is 1, but the tangent of -pi/4 will be -1, because -pi/4 is in the 4th quadrant. We rotate clockwise, and tangent is the slope on the unit circle, and the slope is negative here, so -1. So the final answer will be radical 3 plus 1. Here is the graph of the integrand, secant squared, on the interval from -pi/2 to +pi/2. What we just found was the area under this curve from negative pi over 4 to pi over 3. So this yellow area is radical 3 plus 1. Very often you will be asked to find the area enclosed by the graphs of a set of functions. To do this will require some familiarity with your parent functions like x to the third power. The line y equals 0 is the x-axis. The line x equals 1 is a vertical line at 1. Here's what the parent function x cubed looks like. It goes from concave down to concave up at x equals 0. This is the same as negative 8 x to the third power plus 8. So the transformations are, the parent function will be upside down because of the negative, so I'm going to flip this around, and it will be shifted up 8 because of the plus 8. So y equals 8 minus x cubed will look something like this. The area enclosed by these three graphs is the area that is sort of surrounded on all sides by the blue, the red, and the green. This is the area we need to find. This is the area under the red curve from 1 to whatever this question mark is. So we'll be setting up an integral in a minute, but the limits of integration will be from 1 to question mark. We need to find what this question mark is. In other words, we need to find where the red curve is equal to 0. So let's set 8 minus x to the third power equal to 0 and solve. Adding x to the third power to both sides, we get 8 is equal to x to the third power. Taking the cube root of both sides, we get 2 is equal to x. So that is the second limit of integration. That's the 0 of the red function. I need you to listen to me very carefully, students. You must begin by writing the definite integral representing this area before you start doing calculations. For some reason, students will often jump right in doing the antiderivative and plugging things in. You will not get full credit unless you write this integral down first. Now, according to the first fundamental theorem of calculus, we will evaluate this definite integral by finding the antiderivative next. The antiderivative of 8 is 8x. For the next term, we increase that exponent by 1, and we divide by the new exponent. So 1/4 in the front. Instead of putting a plus c, like we do for an indefinite integral, we apply the limits of integration from 1 to 2, like this. And then this means we plug in the top minus plug in the bottom. So this is what I mean. You take your antiderivative and you plug in the top, minus you plug in the bottom. If this was a test, I would definitely leave my answer like this. Don't risk making a careless mistake in the arithmetic. If you kept going, it would look like this, which would simplify to this, and here I'm making like denominators. This is not looking pretty at all, but here we go. 12 can be written as 48 over 4, so we have like denominators. So the answer on a multiple choice question would be 17 over 4, but again, on a test, I would leave it like this. This curve is the graph of y equals cosine x plus radical 3 times sine x. Let's find the area of this shaded region. So it's going to be the integral of this function from 0 to whatever this intersection point is. So we need to set y equal to 0 and solve. We begin with this. Let's subtract radical 3 sine x from both sides. So basically we're going to move this over to the right, but it'll be negative. Next, let's divide both sides by sine x. So now we have this. This would be the same as cotangent. I would rather deal with tangent. So let's take the reciprocal of both sides of this equation. Turning this upside down, we have sine x over cosine x is equal to negative 1 over radical 3. But of course this means that tangent x is equal to negative 1 over radical 3. So the tangent of what is equal to negative 1 over radical 3? We can find the reference angle by ignoring the negative sign for a second and asking ourselves the tangent of what angle is 1 over radical 3. That's one of those facts that we memorized. So the reference angle is pi over 6 because the tangent of pi over 6 is 1 over radical 3, also known as radical 3 over 3. A reference angle is the angle between the terminal side and the x-axis. Every quadrant has an angle with a reference angle of pi over 6. Tangent is positive where the slope is positive, so first quadrant and third quadrant. Tangent is negative where the slope is negative, so second quadrant and fourth quadrant. In this case, we want the tangent to be negative 1 over radical 3. So that means the solutions will be here and here. In this case, we want the very first solution. So it's going to be this one. And pi can be thought of as 6 pi over 6. So this angle must be 5 pi over 6. So that is the x-intercept. That means this yellow area is the area under the curve from 0 to 5 pi over 6. In other words, the integral of cosine x plus radical 3 sine x from 0 to 5 pi over 6. To evaluate this definite integral, we first must find the antiderivative of this integrand. The derivative of what is cosine? The derivative of sine x is cosine. I see this constant coming, so I'm just going to bring that down. What's the antiderivative of sine x? Well, the derivative of what is sine x? I feel like I better erase this plus sign because the derivative of cosine is negative sine x, so the derivative of negative cosine will be positive sine x. Put the negative out here in the front. So this is the antiderivative. Normally we would put a plus c on the end. However, we don't do that for definite integrals. Instead, we apply the limits of integration with a vertical line like this, 0 to 5 pi over 6. And the first fundamental theorem of calculus tells us to take our antiderivative and plug in the top minus plug in the bottom. So here we go, plug in the top minus plug in the bottom. While in calculus class we don't have to simplify, you must always evaluate trig. You may not leave your answer like this. So what is the sine of 5 pi over 6? We know that the sine of pi over 6 is 1/2. 5 pi over 6 is in the second quadrant, where sine, a y value, is positive. So the sine of pi over 6 will also be 1/2. The cosine of pi over 6 is radical 3 over 2. Cosine is negative in the second quadrant, so it will be negative radical 3 over 2. A negative times a negative is a positive, so I'm going to have radical 3 times radical 3 over 2. Okay, the sine of 0 is 0, so this is gone. The cosine of 0, let me bring down this negative radical 3 for a second. The cosine of 0 is 1, so we don't need to write that. Now that we have evaluated the trig, we could stop here. So this is a full credit answer. I'm going to simplify a little bit more. Radical 3 times radical 3 is a regular 3. So we have 1/2 plus 3/2. That would be 4/2, which is 2. So 2 plus radical 3. This is what you would see on a multiple choice question. Finally, let's do that same problem again using the calculator. Start by entering this equation as y1. Actually, always start by resetting your calculator by hitting second plus 7, 1, 2. That's second plus 7, 1, 2. That gives you a fresh calculator. Now hit y equals and type the equation in right here. Let's hit graph and see what we've got so far. Okay, so we're looking for this little area right here. So let's adjust the window. You know what would be fun? Let's use zoom box. So I'm going to hit zoom and choose option 1. Move the pointer to the lower left of the area of interest and hit enter. And now move the pointer to the upper right of the area of interest and hit enter. So that just zooms right in on the area that you want. So let's pretend that we are doing the calculator method exclusively, so we don't already know the 0, the x-intercept. So let's find that. Go back to y equals. The easiest way to find an x-intercept is to graph the x-axis itself. So I'm going to put a 0 right here. So now if we go back to the graph, we can find the intersection point by hitting second trace, option 5 for intersect, move the pointer close to the point of intersection, and hit enter 3 times. Enter, enter, enter. So this is the point of intersection as a decimal, the x-intercept. Let's store this into a letter in the calculator. So go ahead and hit second quit to get to a blank screen, and immediately hit X and then store, and let's do alpha A, enter. So that value has now been stored in the letter A. On your paper, write A equals 2.6179. The College Board will accept 3 decimal places. However, students will often try to round to 3 decimal places and they round wrong. So my strong recommendation, always use 4 decimal places and never try to round. To get credit on a calculator problem, you must show the setup of your definite integral. Now that we have defined A as 2.6179, you can just write A into your integral expression. So this area is the integral from 0 to A of the cosine x plus radical 3 sine x dx. So how do we evaluate this on the calculator? First of all, remember that this integrand is y1. So on the calculator, we're going to type in the integral from 0 to A of y1 dx. By the way, don't write that on your test or the AP exam. The College Board doesn't want to see calculator notation. To the calculator, to make the definite integral show up, you hit Math, and then you choose option 9. We are integrating from 0 to A, so we can type in 0, and then alpha A. And we are integrating the expression that is in y1. To make y1 show up, we hit alpha, trace, and then by default y1 is selected, so you can just hit enter. Just put an x for your dx, and that's it, just hit enter. So this is the answer. Again, always use 4 decimal places and don't try to round. So let's put 3.7320. And that's it. This is what your work would look like for a calculator problem. Just for fun, let's compare this to the answer that we got before. We had 2 plus radical 3, yeah? So back to the calculator, let's do 2 plus radical 3. Kabam! A perfect match. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.